Here we go. We have a question: merge two sorted linked list. So you have given the head of two sorted linked list consisting of nodes. The task is to merge both lists and return the head of the sorted merge list. So we have given head 1 as 5 and head 2 pointing to 2. So this is a linked list, this is a linked list. So the linked list is in sorted order. We have to merge both linked lists and return the answer in a sorted order. So this is the answer. And this is another example, and the answer is in sorted order. So it is pretty straightforward question. Let's try to build the approach. We have root 1 and root 2. We have to create one separate linked list that will represent both linked list in a sorted order, and we have to merge both linked lists. So first of all, we need to create -1. This is my head, answer head. Then I need to append the nodes here. I need to append nodes here, nodes here. And for this also, we need one pointer, pointer 1, pointer 1. This is pointer 2, this is pointer 1, pointer 2, pointer 1, pointer 2. So that's how this will work. We're gonna use two pointer approach. We have current 1 pointing to root 1, current 2 pointing to root 2. We have to check which node is smaller. 2 is smaller, so we will append after, we will append it on the last. So for this we also need current. This is our current. We will append the smaller node after the current node. So we will append 2 here. So as our current one incremented, we have to position current one to its next node and also shift current. Then we have to check which node is smaller, C1 or C2. C2 is smaller, so we will append the node here. We will create new node and insert after the last node. Then we will increment current 2 because current 2 is added, and also current because current will point on the last node. So again we have two nodes, 5 or 20. Which is smaller? 5 is smaller, so we will create new node. Then C1 will increment, means point to the next node, and current will also increment, means position to the next node. Then we have 10 or 20. 10 is smaller, so insert 10, create a new node with value 10 and increment C1 and increment current. Then which is smaller? 15. So insert 15, then increment, then uh, increment. Then which node is smaller, 20 or 40? 20 is smaller, so 20 will be added here. C1 will point to the next node, current will point to the next node because 20 next is null, so C2 point to null. So now we cannot compare the values. If C1 is not null, means there are some nodes in list 1 which is not added in our answer. So we just need to add C1 here. So just add C1. So C1 means all the nodes will be added. Like this. If C2 not equal to null, we will append C2. So we have two nodes. We don't need to create two nodes. We can just utilize C1 and just add C1 linked list directly. No need to create individual nodes. So then we have the answer. Just return the answer, but answer will give you incorrect answer. We need to point to the next node. So the answer starts from here. So the expected answer will be head next. Head dot next is our answer, is our real answer. Now let's code this. Code is very simple. We have head, current, current 1, current 2. Current 1 and current 2 is for head 1 and head 2. This is our answer, means head, and current pointing to answer. While we have two separate nodes, first compare the values. If current 1 data is smaller, pick current 1 data and create new node. After that, current 1 move to the next node. Else current 2 data is smaller, create new node with current 2 data, and current 2 node will position to the next node. Current will anyways shift to the next node because we are creating a node on if block and else block. So this condition will always be true. Current will point to the last node in our answer. If current one not equal to null, means there are some nodes in our list one, so directly pick the link list. No need to create nodes individually. Same applies for current 2. If it is not equal, directly add current 2 and at the end just return head dot next. Let's submit this. Let's talk about time and space complexity. So let's submit this. Now let's talk about time and space complexity. In this code, the time complexity is order of n plus m, whichever is maximum, and the space complexity is constant. Why constant? We are creating new nodes, but why the space complexity is constant? Because we are creating a node on each step and it will not take any extra space apart from the input. So we have solved this using the expected time and space complexity. So we have solved this question. If you like this video, give it a thumbs up, subscribe to this channel, and thank you all for watching this video.